you just see, if you plot the stress and strain in the left side graph is basically for a mild steel, and right side graph is for the brittle materials such as concrete. So what happens if you plot stress and strain? So stress basically we plot in the vertical axis and strain we plot in the horizontal axis. So if you plot stress and strain initially, you will find the initial portion is linear, so it is a straight line, and up to certain point that stress is proportional to strain. So that point is basically called the proportional limit or the elastic limit. But problem is that most of the material do not show that proportional limit or elastic limit. So it is very difficult to get. We have to get that Young modulus from the initial portion only. So here you just see for this brittle material in the right side graph, you see that its graph is almost non-linear in nature from the beginning. So it is very difficult to get that proportional, and there is no such proportional limit or the elastic limit. Okay, so what we have to do now? We have to draw a tangent at the initial portion of the graph, and so that we can get some ratio of the stress and strain, or you can say that angle of this tangent. From that angle basically indicate your initial tangent modulus or Young modulus or modulus of elasticity. Okay, so I was discussing that most of the metal normally shows linear portion, and it is easy for us to get the elastic limit or Young modulus. But there are many material in which we cannot get that straight line. So from you just see from the right side graph, it is very difficult to get the straight line. In such case, either you have to use initial tangent modulus, or you will find there are many terms in the literature that is called only the tangent modulus or the secant modulus. So there is a basic difference between the initial tangent modulus, and the secant modulus. We will see in the next slide what are the basic difference between the initial tangent modulus, and the secant modulus. So right now we have discussed that Young modulus is the ratio of stress versus strain in the linear zone, and up to which stress is proportional to strain is called the proportional limit or the elastic limit. Most of the material do not possess or do not show elastic limit, so it is very difficult. So what we have to do? We have to get a tangent. We have to get a tangent from the initial portion of the stress strain curve, and you have to use that tangent for linear analysis. If you want to go for non-linear analysis, then we have to use the tangent modulus or secant modulus. So we'll see what are the basic difference between the initial tangent modulus, and the secant modulus. Here you just see that the stress strain is non-linear nature. So what happens if you draw a tangent from the initial portion of the graph is called the initial tangent modulus. We represent as here EI. So this graph is here EI. That initial tangent modulus also sometimes called short-term elastic modulus, because that modulus we are used for linear analysis in concrete also. And tangent modulus, basically the difference between initial tangent modulus and tangent modulus is that initial tangent modulus we draw the tangent at the initial portion of the graph, and for the tangent modulus we can draw at any point and we get the slope, and from the slope we can find what is the tangent modulus. Now another term is the secant modulus. Secant modulus is basically a straight line which connects the 2 points. The term secant means a straight line that intersect a curve in the 2 point or the more point. So for this stress strain graph, we can have the secant modulus between the 2 point. So first point we normally choose the initial point, and second point we can choose any other point. So here we assume the P point, where we just draw that one tangent. So if you connect the 2 point initial point and the origin point and the P point, that straight line or the slope of the straight line is called the secant modulus. You can see from the graph that initial tangent modulus is basically coming from the beginning or the straight line, or you can say from the linear zone. But tangent modulus and secant modulus we are getting from the nonlinear zone. So from there you can get one idea that if you want to go for linear analysis, the initial tangent modulus is sufficient for you. In this concrete design, we will go through the initial tangent modulus only. We will use only initial tangent modulus. If anybody want to go for nonlinear analysis, then he should use tangent modulus or the secant modulus. Here you just see from the graph you can find that initial tangent modulus normally come higher than the tangent modulus or the secant modulus. And secant modulus sometimes give reasonable result when we connect the 2.1 in the origin and another 1/3 of the maximum compressive strength value. Suppose FCK is 20, so that 20 by 3 it is coming 6.33. So if you connect the 2.1 in the origin and either stress at the stress of 6.33, and that line you will get the slope basically is your give a secant modulus, and the secant modulus value is very reasonable, or you can see which is in comparison to your initial tangent modulus is very accurate, or you can see accurate, or it will be better to use term acceptable. Secant modulus basically we use for nonlinear analysis, or you can say whenever you will find that linear analysis or linear or initial tangent modulus is not giving proper result. In that case we should go for secant modulus. So since for the concrete the graph is nonlinear almost from the beginning, it is very difficult to get the Young modulus. So IS code come up with the idea of that Young modulus is equal to 5000 root under FCK. So suppose you conduct one test and you got the characteristic strength value, or you can see if you know the grade of concrete, from there you can find what is the value of initial tangent modulus or Young modulus. So initial tangent modulus, many of book write EC, so I also denoted EI or EC, or that EI or EC, that basically initial Young modulus or modulus of elasticity is equal to 5000 root under FCK. So this is the property of the concrete, or you can say there are many modulus, initial tangent modulus, secant modulus, and the tangent modulus, and from there we will choose initial tangent modulus for our concrete design purpose, and the value of this initial tangent modulus is 5000 root under FCK.